So can you see now what's on my screen?
Yes, sir.
Yes, sir.
So this is
Yes,
the
sir.
course
Yes,
outline.
yes, sir.
So this is the course outline that we have. Chapter 1, which I hope na mahuman na. Naturong adlawan. Then chapter 2. Then chapter 3, torsion, shear moments in beam. And then stresses in beams, beam deflection, displayed beam, and continuous beam. So I don't know if
Oh, tao.
makaabot pa ta diri sa continuous beam because gamay na lang kayo sa time para mahuman ang atong semester. Actually, ang atong midterm will be on April, I think, second week of April, if I'm not mistaken. So we will have our midterm. Mo-follow lang ta sa university calendar. So to start the discussion proper, this subject is the mechanics of deformable bodies. And as what you can see from my screen, um, mechanics of deformable bodies is just actually part of engineering mechanics. So in engineering mechanics, you have learned, by the way, nag-feedback sa inyo or wala ra?
Nag-feedback, sir.
Kita ra, sir.
Feedback, sir.
I mean, feedback sa inyong sounds or wala ra?
The echo, sir.
The echo,
May
na,
echo,
sir.
sir.
Wala ra clear, ah?
I echo, sir.
Anay echo. So, ano pagtanong ko? Ako gi-off na lang. How about this one? Kani murag wala na sa?
Okay na, sir.
Okay. So again, mechanics of deformable bodies is just another branch of the engineering mechanics, and an engineering mechanics is composed of three components. One is statics, the other one is dynamics, and the third one is the strength of materials or the mechanics of deformable bodies. In the previous curriculum, it is called as strength of materials, but now in the new curriculum, it is now called deformable bodies. But basically, the contents are just the same. So in statics and in dynamics, you basically focus or you study the external effects of your structure to your rigid bodies. Rigid meaning to say that bisan unsang force ang imong i-apply into a certain system or into a certain structure, you neglect the deformation that your system is undergoing or your system is experiencing. So in statics and in dynamics, you consider only that the system is rigid. However, in mechanics of deformable bodies, you now consider the effects of deformation regardless kung unsa kagamay ang deformation nga imong structure is experiencing. So these types of deformation will be in the form of stresses, will be in the form of elongations or shortenings, will be in the form of strain. So regardless, naagyoy some point of deformation nga ma-experience ang imong structure because as I've told you before, there is no such thing as a perfectly or a material with a infinitely elastic material. So the mechanics of materials deals with the behavior of solid objects to stresses and strains, and then the ability of the material to withstand and apply load without failure or plastic deformation. Now, why do we have to study strength of materials? Or why do we have to study mechanics of deformable bodies? Of course, it is essential to study the behavior of material from the strength and deformation point of view, as well as the characterization of different kinds of forces which may cause different stresses in material. And then, Chris, Chris, nakadira, Chris?
Sir?
Yes. I want you to describe the picture on the left. And what do you think is the significance of that picture in relation to our subject, stresses?
Kwan, sir, kaning jack man siya, sir. Kanang mo aswat siya og pila ka tons nga kwan. Sa gamay ra siya ba?
Yes.
Na-force ang kwan ang kaning sa jack, sir, kay sinahan man hydraulic man na siya.
Okay. So how Batadlan, can you describe to me what can you see on the picture on the right side?
Ang sa
Batadlan
different,
Justin.
yes sir. Ang sa different sa both pictures sir.
Yes, you may proceed.
Ang difference kay ang sa first ang sa nasa left picture kay um nasa ilalom ang force niya ginapataas siya while sa other sa on the picture sa right kay ginabira pataas ang force kay naa sa
Naasa-asa man.
hello.
Yes, yes. We can
Yes,
still
sir.
hear you. Oo.
Sir. Nadunggan
So,
tong last?
wala kayo ko kadungog.
Yes, sir. Ako pasok ang sa nasa right side kay bira siya sa taas ang object or ang material while ang sa left side kay gina-push siya pataas ang material.
Okay, so Neil sa ladata. Nakadira, Neil? Neil. Is still around? Well, I'll just try to explain this to you now. The picture in the left. So the picture in the left is, as you can see, a car that is being lifted by ilalagay ni ka on jack supports. I think murag na siya 4 hydraulic jacks. While on the picture on the right, it is a container van being lifted by a boom crane. So, as what you can see from here, if you try to look at, there will be some kind of asa man ang atong mga stress distributions diri. Which part of the system is kanang mostly stressed? Nico, honest. Nico,
Yes, sir. Sa asa nga picture, sir?
sa picture on the left.
Ang stress para na sir sa picture nga nasa left, sir, is kanang sa kuan, sir. Kaning sa taas aning sa jack gani, sir. Kaning naga-compact sa jack o kaning sa car. Diya nga area, sir.
Somewhere here. That one.
Yes, sir.
How about Israel? What can you
So, sir,
observe? Asa padulong ang atong stress there is a picture on the right.
ang stress, sir,
Yes.
sa
What do you
ground,
think is the
sir,
most No, there is a
kanang
picture in
sa
the
lower
kay
part,
Boom
sir,
Crane.
doon sa ground.
Could you please go on answer a bit? What do you mean the lower part?
Para na ako, sir, ang pinakadakog stress is ang sa doon sa ground gani, sir, nga part sa machine kay mo man siya ang nag-hold sa machine nga para
Okay.
ma-upright siya.
Correct. There is a very good observation as well. But what I'm really trying to explain here, there from the picture in the left, you can see that there is a compressive force. The compressive force is being distributed into the jack stands or jack supports. Asam nagikan ng atuang stresses nila or asam nagikan ng atuang force, which is distributed padulong sa atuang jack stand. Asa gagikan ng force? Purple.
I
Purple?
think the force is from the car, sir.
What do you mean from the car?
Yes, sir. Am I audible?
Yes.
The car that is placed above the jack, sir.
What do you car? From what specifically part of the car?
I think, sir, pardon.
Asa man gikan or unsa man nga part sa car ang naka-contribute sa force? Of course,
Sa body sa car, sir.
the body in the car. The body in the car, has a mass, and because of that mass, because the car has mass, it creates a force padulong dito sa imo nga jack supports, right? And on the other side,
Yes, sir.
this container van certainly has mass, and because it has mass, it has weight, and because it has weight, the weights are now redistributed to the support points. Now, remember class that whenever there is a contact, there is a reaction. So, kung asa ra diyan atong mga contact points, dira ra mo bukura nga atong mga reaction. So, in this case, as you can see from the picture on the left, the contact points only are kanirang ato ang mga point of contact diri sa ato ang mga jacks, and on the other right side, this is where the force goes. So kinalagay na siya whenever there is a force going down, there should be a force to counter to put it into equilibrium. There should be an opposite direction na force. Now, since the weight of the car is the one causing stresses to these jacks, therefore there has to be an internal reaction that has to develop within that jacks. And also in this container van, there are tensile forces that is being developed in these ropes. So these the stresses are being developed. So these stresses are actually the internal resistance of the materials to the distorting effects of the external load. So if there is no load, there will be no stress, right? So if this car is weightless, then there will be no stress that will be developed in these jacks. And also, if this container van is weightless, then there will also be no forces that is developed. Now, I'm trying to show here that there are two types of forces here. One is in compression, and the other one is in tension. The compressive force allows the jack to there will be some kind of deformation nga ma-develop sa imo nga jack. And because of that deformation, there will be some kind of internal resistance which is in the form of stress para to counteract that effect of that stress. And so, diri po sa pikas, there will be some kind of deformation nga ma-develop sa ato ang rope or cable, and the compression force will make the jack shorten because it is experiencing compressive force, whereas this cable will mutaas siya, mo-elongate ato nga cable, and because ni-elongate siya, that is due to the tensile load that is being developed in the ropes. Now, because of stresses, we will also be experiencing deformation of the material. So what is the deformation of the material is now what we call the strain. So this topic is all about stress and strain. So I want you to be familiar with these two words, the stress and the strain. Stress is just the internal resistance of the material, whereas the strain is the deformation of the material under stress. So with this, there is a picture sa ato there is a picture sa the left side, the stresses are developed there is sa ato ang jacks. Whereas on the picture on the right side, if we're only looking at the cables and the container van, there will be some stresses that is developed in the rope. Now, if you're going to calculate, pila man ang stress, sir? No, I want to mathematically calculate o pila ang stress na na-develop sa ato ang jacks and pila ang stress nga atong na-develop diri sa, what you call that one, the ropes. Now, we can calculate that later. So, mathematically, we can represent stress in terms of just the load over the areas of contact. So there are different types of loadings. We have transverse loading, axial loading, and then torsional loading. So transverse loading is just the force applied perpendicular to the longitudinal axis of the member. So we know that has to be applied perpendicular to the axis of the member. So when you have a beam, a very good example of this one is a beam. This is a beam. And then if the load is acting perpendicular to the axis of the member, then that is what you call a transverse loading. And axial loading is a force that acts along the axis of the member, or it is collinear to the longitudinal axis of the member. And then we also have a torsional loading, which cause twisting of your system. Now, this is for representation. This one is the transverse loading. So the one that is contributing to transverse loading is this one. Kaning mga yellow arrows. So this one is acting perpendicular to the direction or perpendicular to the axis of your beam. So this one is your beam. And then if the load is acting perpendicular to that one, then that's what you call a transverse loading. Now, transverse loading, because of this loading, what kind of deformation nga ma-develop? Of course, because of that, there will be some kind of deformation. Ang imong beam will try to behave something like that. Mura siyang babahog. Can you see it, class?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
so
sir.
that is the transverse loading. Now we also have an axial loading. So an axial loading, kung sa may tabo sa atong axial loading, what is a very good example of axial loading based on your observation? Sige, like Judiel. Nako, naman dyan ang imong. Yes.
One trial, sir. Ang sa axial loading, sir, right? Kaning sa jackhammer, sir. Patungan o kuan.
Yeah, that is a very good observation.
Yes, sir.
Another one is also a column. Can you see a column? Inyong balay? Mga column?
Yes.
Oh, so for example, this is the roofing system. This is your truss. Excuse my drawing, but educate ko mo drawing. But this one, because of the loads that is coming from the truss here, there will be some kind of axial load that is going to your column. So your column is actually experiencing axial loads. So the beam usually experiences transverse loading, whereas columns usually experiences axial loadings. No, there is also another type of loading that is what you call a torsional loading. Now, this loading is the one that is caused your material to be twisted or para makuan siya kanang pareha og maglaba ka nga magpuga ka, you're trying to twist something. And in structural theory, or when you design a particular structure, you always have to, as much as possible, you always have to avoid torsional loading. If there is some kind of torsion that is going to develop into your system will be somewhat unstable and then will eventually need to collapse. So when you're designing structure, you will most of the time you have to frame your system such that you can avoid torsional loading. So stresses, these are the stresses, or these are the stress terms that I want you to be familiar with. Number one is the compressive stress. So this stress is developed when your member is subjected to a compressive force. So this stress usually makes your material to reduce the length of the material. So this maka-visualize naman taon sa compressive stress. No, we can usually visualize what is compression and tension, no? Okay, na hindi na tayo magkalisod na sa. Okay. So, and then if we have a compressive stress, then the opposite of that is a tensile stress. So, it makes your material elongate. And then we also have a shearing stress. So, a shearing stress happens when you have two, for example, what do you call that one? For example, you have these two. So, for example, you have these two wood planks, and then you put a screw here. Na kay screw nga gibutang, you have a screw na gibutang dirang dapita just to join these two parts of wood. Can you visually on it? Can you see it?
Yes, sir.
Yes, sir.
When you try to birahunin mo ning this one and the other wood planks in the opposite directions, because shear develops whenever there are two forces that is happening simultaneously in the opposite direction. So can you see when you try to when you try to kanang birahon ni siyang imong material, there will be some kind of a shearing stress that is developed in your material. And the shearing stress usually will try to cut your material. Usually, asa man natong point of cut ani? One lang. Hypothetically, asa man ma-cut ang ato nga section.
Kanang
Ato nga bolt.
kanto nga sa mga kuan sir kanang usa na siya rivet ya, usa na imong kuan
Yeah,
sir
this is a rivet, or let's look at it as a bolt. It can be a rivet or it can be a bolt. Let's just say this is a bolt. Asa man ma-develop ang ato nga shear stress ani? Kim.
kuan sir between anang duha ka plank sir like dili na umakuan pero dili between
This
yun
one?
aning ano sir.
This one, kaya akong gilingin.
Oh, diya sir tunga ana sir sunay tendency maputo ning mga
Yes,
connection
that is correct.
ni.
So because of that, because of these two opposing forces, your bolt is actually experiencing a shear stress. And kanang akong gilinginan, that is where the shear stress that's going to happen. And then what is this bearing stress? It is different from compressive stress in the sense that the latter is internal stress caused by compressive force, whereas the bearing stress is the contact between. So bearing stress is just actually mapagkamala ni siya as a compressive stress. However, this is a different type of stress because bearing happens at the point of contact between two materials. So, Cabrera Mark.
Yes, sir. Yes, sir.
Yes. Based on the figure nga akong i-drawing diri, we have a two wood planks joined by the bolt. Asa mag-develop ang ato ang bearing stress? Mark.
Kanang I think sir diha sa kuan sir. Diha sa kanang at the kanang murag abutan sa duha ka kuan kahoy ganing git kahoy nga gitapot na ning sa imong kaning sa draw di sa taas sir.
Asa man dapit? Asa to yung giingon?
Diya daw dapit sa ano sir, for example sir kanang taas nga plank sir.
Yes.
Taas nga plank ay wait sir ako sa kanon. Taas nga plank so for example sa taas nga plank na tensile force na kuan so likod aning bolt sir na diya ang bearing stress may tabo yeah.
Likod sa bolt nasa left side or sa right side?
Kuan sir kung sa upper nga plank sir.
Yes, sir.
So nasa left side sir. Nasa left side sir.
This side, getting A, there is a A.
Dili sa pikas ana sir.
Okay.
Pikas.
So there is a B.
Yeah, dun sa pikas pod sir sa lalom kaning under sa A.
Okay.
Yeah.
So you are correct. So the bearing stress. So looking at this picture, when we're looking for the bearing stress happens at the point B. This is where the bearing stress happens during a section. At the point of contact between the wood plank and the bolt. That is where the bearing stress occurs. Now, there is a bottom plank. The bearing stress happens at the point A. So, during the pita. So, can you now visualize, or you can now identify these different stresses na ma-experience mo nga structure. So obviously we can easily visualize compressive stress and tensile stress, but the shearing stress we can easily see shearing only occurs when you have two opposite forces, and then the bearing stress only happens at the point of contact. Yes.
Sir, ni question. Kita sa shearing stress, sir. Ayan, stress na jud sa tunga.
Yes. Kung asa siya dapit ikat.
Circular nimo.
Yes, kung asa siya dapit makat. Potentially nga makat.
Makat. Sige, sir. So, ang bearing kay katong point of contact.
Point of contact. Yeah, that is correct.
Thank you, sir.
So let's have this as an example. Before that, before that, nagmuna itong discussion last time. So let's ganun lang. So we have here an example. We have two rods that is applied with traditional type of force atong gi-apply sa atong rod. Hello? What type of force ang atong gi-apply sa atong rod?
Yes, sir. Tension
Yes.
force, sir.
Yeah, that is a tension force. So we have rod AB and then we have rod CD. Both rods have the same length. Rod AB is applied with 500 Newton of a tension load, while rod CD is applied with 5,000 Newton of tension load. My question is, which of these rod is more stressed? Which of these two rods is more stressed? Now, Kim De La Torre. Yes?
Both, sir, kay same raman ang amount nga gihatag ang load.
No, that is not. As you can see, the other one is 500 Newton, while the other one is 5,000 Newton. So they are not experiencing the same loads.
Okay. Ang amount, so CD ang mas stress kay sir kay mas dako man siya amount. Sorry, nalibat ko sir, ang pinako 500 500.
So CD is more stressed than rod AB.
AB.
Okay. So, John Mark de Guzman, in your point of view, which one is more stressed? John Mark?
Ako, sir? Gonzales.
Yes. Ay, Gonzales there.
Because I think sa CD pud sir kay mas dako man ang yung force, yung tension force compare sa AB.
Okay. So what if we make this one? Sige, another idea from Chris Mark. Chris Mark,
Yes, sir.
which do you think between these two rods is experiencing more stress? Is it
CD,
rod
sir.
AB or RAM CD? Why RAM
Rod.
CD? Why rod CD?
It has more force, sir. 5,000 newtons than red AB.
Okay. So how about we make this rod shorter? Sige. We make rod CD shorter. Now, in this case, which now is more stressed? Wakay Leia.
CD, sir.
CD Japon. Because,
Yes, sir.
anong CD man?
Because ang force niya is mas dako man Japan, sir, kaysa sa AB.
Okay? Kinsa may mo object that rad AB is more stress compared
CD, sir.
CD Japon ka Kim. Ikaw, Neil.
Hindi ko rin sa CD Japan, sir.
Yes, sir. Kay, sir, kung maximum ang area, sir, gamay ang stress mabuo. Pero kung ang minimum ang area, dako ang stress mabuo.
That's basically I want to fun. I'm asking you, but you automatically say that it is CD because it has a greater force. No, when we talk about the concept of stress, you have to first identify or you have to first know two things. Because the stress, as what I've said, is the force over the area. We do not know yet the area of this one. We do not know yet the area of AB, and we do not know yet the area of CD. And hence you already make a conclusion that bar CD is more stressed. How can you say that? You do not know the areas of the bar. I'm talking about stresses here. I'm asking about the stress. And we know that stress is just the force over the area. But since we do not know the area of these two bars, we do not know the area of bar AB, and we do not know the area of bar CD, how can you easily conclude that bar CD is more stressed just because it is being applied with a greater force? Of course, you cannot do that. You have to find these two forces first. You have to understand first that it requires two parameters before you can say that one is more stressed than the other. Neil, could you please turn off your microphone? So can you understand now the point that I'm trying to say?
Okay.
Yes, sir.
Yes,
Yes,
sir.
sir.
You cannot
Yes, sir.
you cannot jump into conclusion that the one is more stressed than the other just by looking only by one parameter. We're talking about stress here. We have to understand that it requires two parameters. We have to know the force and we have to know the area. But since we do not know the area of these two bars, then we cannot decide, or we do not know first that bar AB is more stressed than the bar CD. Okay, I hope you get the point. So let's say that the bar AB is the area of bar AB is just 50. mm squared, whereas the bar CD we have 5,000, or let's say 5,000 mm squared. So can you now Juan, see which one of these two bars is more stressed?
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Which one is
Yes,
so
sir.
which one is more stressed? So we will now try to calculate kung asa ang mas stress ani. So for stress AB, we have the force AB over the area AB. So what is the force AB? We have 5,500 newtons over 50 mm squared. So ilang stress? Could you please calculate?
10, sir.
Answer.
So this
Answer.
is
10.
then what is the unit?
Newtons per meter.
Newton
Megapascal
Newtons
to,
per
sir.
mm.
Pascal, sir.
mm squared.
What's that? Newton per
Mm squared.
Mm squared.
Millimeter.
mm squared. So this is not
Pascal.
omega. Yes. How about the other one? So stress CD, we have the force 5,000 Newton over 500 mm squared. So pilang stress?
5,000
Sir.
guro, sir.
Imong area, sir, is 5,000.
5,000. This is 1 Newton
1
per.
Newton per millimeter squared.
Meter.
So between these two, asa man ang more stress?
AB, sir.
EB, sir.
Maybe, sir.
Beam
AB,
AB
sir.
is more stress. So how can we get So that's the concept of stress. So I hope you nasabtan na ninyo. And the concept of stress, you need two parameters before you can decide which one is more stressed over the other. So let's look some more examples. So this, a composite bar consists of an aluminum section rigidly fastened between a bronze section and a steel section as shown. So the axial loads are applied at the positions indicated. Determine the stress in each sections. So can we easily identify the stress in each material? Do we have the force in each material?
Dili pa, sir.
Do we have the force? Can you identify the force? We have, is this 4,000, 9,000, 2,000, and 7,000 not a force? Or is it a force?
It's a force, sir.
This is the unit of force. And we also have the unit of area. The bronze, aluminum, and steel, we have 1.2 inch squared, 1.8 inch squared, and 1.6 inch squared. So we have the areas. So we can now calculate the stresses in each material. Correct or not?
Yes, sir.
So we can now calculate the stress in each material and then identify which material is more stressed. Tama sa?
Yes,
So let's have this example and let's calculate the stresses in the material. So how are you going to calculate for the force in your bronze? Kung saan na to pagkabalo ang the force that our bronze is experiencing. By the way, is this system in equilibrium or not?
Dili pa, sir.
Dili, sir.
Yes, sir.
Antoinette, sige, Mel, Antoinette. Is this system in equilibrium or not?
Dili sir kay kanang compress og 7,000 pounds diri sir pero diri sa aluminum is mas dako man ang force sir.
Wait, sana, compress ka og 7,000 diri sa steel and then sa aluminum. Pila sa aluminum?
11,000 sir.
11,000. Okay. So what is your concept of equilibrium? By the way, what is your concept of equilibrium, Mel Antoinette? When do you say that the system is in equilibrium? Because you said that this system is not in equilibrium.
Ay,
so what is your
sir? Everyday correct sir.
Yes, yes.
Ay for me sir equilibrium na sir kay nagkuan di og 4,000 diri sa pika sir so mahimo siya murag ang force na nagpaingon sa left is 11,000 pounds tanan sir.
And then the force going to the right is also
Is 11,000 put sir.
So this makes this system what? Equilibrium or not? Correct.
Equilibrium.
This system is actually in equilibrium. This system can stand on its own, without the need of a support, because this system is already in equilibrium. If you take the summation of forces going to the right, that is 9,000 plus 2,000, that is 11,000 pounds. And if you take summation of forces going to the left, this is 4,000 plus 7,000, this is also 11,000. So forces to the right is equals to forces to the left. That makes the system in equilibrium. Okay. So when do you say that this system is not in equilibrium? Let's first talk about equilibrium because we will be using that. So when can we say, let's say for example, wala ning dere. We'll just ako ni siyang i-copy and then paste. Let me just grab this one. So for example, these are the forces nga exposed ang imong system. You have 4,000 going to the left and then 9,000 plus 2,000 going to the right. So is this system in equilibrium or not?
No,
Not
sir.
No, sir.
No, sir.
How do you make this system in static motion? How do you make this system in equilibrium?
Summation of forces horizontal, sir. Oh.
Yes, that is the summation of forces horizontal. Summation of forces horizontal. X is going to the right. Let's say going to the right, we have 9,000 pounds plus 2,000 pounds is equals to 11,000 pounds. Summation of forces X going to the left is you have only 4,000 pounds. So right is not equal to left. 11,000 is not equal to 4,000. How do you make this system in equilibrium? Let's call... Sige, Kim again. Kim, how do you make this system in equilibrium?
Mag-assume to sir nga ang point dungangan to usa ka arrow diri sir paingon sa left dayon atoy kuan siya value nga ay bisag unsa nga
Asa wala
letter ba
nasa?
na siya din.
Sige, let's say this is
Modo,
letter
sir.
A, letter B, letter C, and then letter D. At which point imong ipaduga? Yes, Kim, Chloe. How do we make this system in equilibrium? Because everything has to be in equilibrium. When you decide something, it has to be in equilibrium. This system is not equilibrium because the summation of forces is not the same. How do we make this system in equilibrium? Vanessa Jane, let me hear your opinion. Vanessa Jane? Vanessa? Dagang ng out. Anong man yung si problema nga nung nagkahurot niya akong mga estudyante. So let's
Dugan
hear.
nagbayog.
Point B, sir.
Oh.
Dugangan
Sige,
pero
Mark.
kuan sir.
Dugangan ang left side,
I think sir
left side nga force, sir.
dugangan sa left side of 7,000 para ma-equal to 11,000 sir niya. Ma-zero ang yung net force.
Yes, dungagan na
Then
to siya.
equilibrium siya.
Di minsan may dungagan og 7,000. Unsay pasabutan na, unsay implication. For
7,000
example, yeah, dungagan na to siya 7,000 pounds. But in a real life scenario, for example, you have this system, you have a bronze, aluminum, and steel. What material are you going? Unsa man nga material, do you still need to add another material during the pita? Something like that to make para makadungag ang 7,000? For example, this is just your system. You're only limited with 3 materials, bronze, aluminum, and steel. How can you make this system in equilibrium? Sige, Ken. Kay murag kusog ang manok. Sige.
Moad kag force sa bronze sir nga to the left, which is 7.
Muad kag bronze, muad kag force sa imong. And that is also correct. That is a very good observation actually. If you add 7,000 to the bronze,
Nga to the
that
left
makes the,
nga force.
yes, of 7,000, that makes the system in equilibrium. Very good. Can we also do that to the aluminum? Also okay.
Yes, sir.
Actually, if you encounter a system like this system is not in equilibrium because all you have to do is you add a support. You have to add a support here. So this is now your support. So because of that, can you get the reaction sa imong support? This this is now your end. The point D has now become your support. So when this is a support, meaning to say it is not anymore moving, this point is now stationary. This is where you attach your system. So this is the support. The support is where you balance the system. This is where you equilibrium, you put your system in equilibrium. Na gets ninyo ang concept of support?
Yes, sir.
Because if wala kay
Yes,
support
sir.
sa imong if wala kay support sa imong system, then that is only okay if your system is in equilibrium. But if your system is not in equilibrium, then you need to add a support. Thus, the concept of the support is that it makes your system equilibrium. It makes your system balances the forces out. So we will discuss later about this one. So let's just go back to this one. So how do we calculate the force in our bronze? John Mark.
One, sir.
John Mark.
Sir?
How do we calculate the force in our bronze? What do you think? How do we? Stress. We know that stress is the force over area, and we know that the area of the bronze is 1.2 inch squared. But what is the force in your bronze?
Excuse me, sir. Kanang 4,000 pounds, sir. Unit na siya sa, force na siya, sir.
Yes, the pound is a unit of force in the English system. Balik lang sa, we have two system of units. We have the SI units and we have the English units. In SY units, the force is expressed in terms of Newton. The force in the English system is in terms of pounds. So both are forces. So Newton is a unit of force in the English system, and pound is a unit of force in the English system. So this system na akong ipakita nimo is in the English system. So 4,000 is a unit of force. So John Mark, ilang stress ato ang bronze?
Kuan, sir. What's up? Sa bronze, sir, sa...
Bronze lang, bronze. Because we have to segmentize it. Bronze, aluminum, and steel. And then we have to know which system is more stressed.
Sir.
Do you have an idea or you may pat someone? Just give it a try.
Gitry na akong kuan, sir. Divide ang 4,000 divided by... Kanang area maning sa bronze yan, sir, sa kaning what?
Yes, sir.
1.2?
4,000 divided by 1.2. So that is...
Yes, sir. 3,333
pounds per inch squared. Okay?
Yes, sir.
So ingon si John Mark that the area of our bronze, I mean the stress of our bronze is stress of the bronze. So BR is equals to the force in our bronze is 4,000 matupang John Mark, and then the area is 1.2 inch squared. So pila stress ay ang bronze?
3,333.
3,333.33. Okay. This is pounds per inch squared. Now, how about for aluminum? Because you say that that is now 4,000 divided by 1.2. How about with this aluminum?
2,777.770 PSI, sir.
How did you come up with that one?
One, sir.
What is the force in your aluminum?
5,000, sir. 5,000 pounds.
Correct. So the way to do it, you have a very good one. Advanced Kim. So the way to do it, the way to calculate the forces in our bronze, aluminum, and steel is we do it as what I said kanina, is we segmentize it. We cut the sections, and then when we cut the sections, what do? Since we cut the sections, we expose our we expose our internal reactions. By exposing our internal reactions, we will be able to know the stresses. Correct? Because the stress is just the internal reactions. And kung saan man nato pagkabalo sa atong internal reactions, and that is when we cut the system. Correct? Ana. So, asa man nato atong mga cut points. So, we cut the system here, we cut the system here, we cut the system here, and then we draw the free body diagram. So, let's do it. So, this one, this is the cut point. This is the 4,000 pounds. So here, since we cut the system, we expose the internal reactions. So this is the force in our bronze. So what is now the force in our bronze? By taking summation of forces horizontal is equals to 0, we will be able to get the force in our bronze, which is 4,000 pounds. Get it? Class, okay?
Yes,
Sabtandra?
Yes, sir.
So that is, this actually is correct. Sakto si John Mark. Now, we now consider aluminum. Itong i-consider itong aluminum. What is now the force in our aluminum? We cut this section here, and then we expose this 4,000 pounds. Mga klaro na sa? And then we also have 9,000 pounds. So since we cut the section in between 9,000 and 2,000. So therefore, ang 2,000, wala pa na siya naabot. Okay? So I am assuming that this is in tension. Forces going to the right is in tension, and then forces going to the left is in compression. So by taking summation of forces horizontal is equals to 0, the force in our, what is this? Aluminum. The force in our aluminum is equals to 4,000 minus 9,000 pounds is equals to negative 5,000 pounds. So FAL, what is this? Since this is a negative, therefore this is in compression. This is in tension. So 5,000 pounds, this is in compression. So this is now the force in our aluminum. Nakuha na class na follow ra.
Yes, sir.
Yes, sir.
And then let's move it somewhere here. So the stress in our aluminum is, by the way, what is this one? Unsa ni nga symbol?
Sigma. Sigma.
This is a sigma. So F aluminum is equals to area of aluminum. So what is the force in our aluminum is 5,000 pounds over, what is the area of our aluminum? 1.8.
1.8.
So pila tong area? Ay, pila tong stress?
2,747.78.
Pwede i-type lang para di kita magkakuan. So actually, it's already 4 o'clock, and then katong naanay naapay mga klase at 4 o'clock, pwede lang mo, I do not mind if mo exit ram. 777.78 pounds per inch squared.
Sir, 2 decimal points imohang rolling sa kuan mga
Yes.
points.
Yeah, 2 decimal places.
Okay.
And then the other one, this is the last one is the steel. So we cut the steel at that section. So sa initabo, we have this one. Ay. And then slimay siya. So we have 4,000 pounds, then 9,000 pounds, and then 2,000 pounds, and then this one. I just assume that this is in tension, so this is steel rather. So by taking summation of forces horizontal is equals to 0, unsa ni? The force in our steel is equals to 4,000 minus 9,000 minus 2,000. Tama ba, class?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So this is equals to negative 7,000 pounds. So F sa steel is 7,000 pounds. What is this? Is it compression or tension? This
Compression.
is compression.
Compression, sir.
So, pila ang atong stress atong steel? We have 7,000 pounds divided by the area. What is the area? 1.6 inch squared. So what is the stress?
4,375.
4375.
Ah?
4375.
4,375 pounds per inch squared. Now, based on these three, which one is more stressed? Which material is more stressed or heavily stressed material? Which is the heavily stressed material?
Steel,
Is it
sir.
the aluminum, the bronze, or the steel?
Steel, sir.
Still,
Steel,
Steel,
sir.
sir.
Steel.
Steel.
Still.
Okay, steel. Very good. So at least now you ano mo idea of how to sa turong usa this one. Actually, when you cut your free body diagram, di ba? This is where your cut kaning tulo siya ka kaning violet nga tulo ga kuan. This is your cut section. You can also draw it on the other side. That will give you the same result. So let's try about the steel. So because kani siya nga nga cut section, di ba? The way we presented it, the way I do it is I consider the left section, di ba? I considered when I cut the portion nga naay sa steel, I consider the bronze, aluminum, and then part of a steel, tama?
Hello.
But you can also do it the other way. If you want to consider your free body diagram nga nasa right side, you can also consider just this one lang. Ayun, saan na siya? This one lang. That one. So, sa una siya yung pag-draw yung free body diagram dirang dapita. So, inana lang. So, dirang dapita is so muna siya itong left nga free body diagram and then so pila nga itong force? 7,000. So I consider it in tension. So nakay 7,000 dire. So this is your force sa bronze. So summation of forces horizontal is equals to 0, you get um, F sub bronze is equals to negative 7,000 pounds. So it's still the same. It is still 7,000 pounds compression. So same ra siya result. So whether you use when you cut your section, whether you use the left side of the free body diagram or you use the right side of the free body diagram, it will still yield the same answer. Okay? Hello? Nagets nga nung na ani? So kinsay wala nakagets?
Sir,
Okay, so
compression man tong aluminum og steel, sir, sa?
aluminum, steel is in compression, aluminum is in compression, and then bronze is in tension.
Tension. Okay. Thank you, sir.
Sir,
Yes?
anang sa last baser nimong gisulat, di ba? Answer ka ng steel, imong nabutang is
Ay.
bronze.
Okay, this is steel. Thank you for that correction. So this is steel. This is 7,000. Okay, so let's have some more examples. I hope nga na-gets na ninyo ang concept sa stress. That is just one. One pa lang to siya. That is just a tip of the iceberg. Murag mo pa to siya ang pinakasayon ng concept. Just want you to understand nga what force, how do you identify a compression, how do you identify tension, and I think we have succeeded in doing that. So you can easily now identify the difference in the loadings, whether it is tension or in compression. Now let's have another example. Now the block of weight W in figure shown hangs from the pin at A. The bars AB and AC are pinned to support at B and C. The areas of bar AB is 800 square meters, whereas the area of number AC is 400 square meters. Neglect the weights of the bar. Determine the maximum safe value of W if the stress in AB is limited to 110 MPa. So what is this 110 MPa? What does it mean?
Yang allowed stress, sir, before siya ma-fail.
So this is the stress. The stress in AB is 1,100 MPa. What is the unit? Unsa ning MPa? What is it? Because kanina,
Megapascal, sir.
the unit
Megapascal, sir.
Megapascal, sir.
that is the megapascal. And unsa ni siyang equivalent? Because kanina we are using Newton per mm squared to na? Tama?
Yes, sir.
Okay.
Okay. At least you know what is MPa. And then the stress AC is 120. So nganong lain-lain man siya stress ting duha? Nganong lain-lain man og stress ang AB og AC? What do you think? Nganong AC has a higher stress capacity than stress AB? By the way, what will happen if these stresses are exceeded? Let's say if we calculate the stress at member AB is greater than 100 or at the stress at AC greater than 120, what will happen to our system?
Mag-fail, sir.
Mag-fail. Unsa? Yeah, fail. When we say fail, unsa nga klase nga fail? Unsa nga? Sige, let's identify unsa nga mga mode of failures nga inyo ang nahibaw-an. Buena Vista, Kevin Lee.
Wala ka ba, sir?
No idea. Hamito, Jemima. Jemima. So absent si Jemima. Not around.
Sir,
Where were you? Were you not listening? Now, my question is, what will happen? Because the system says that we have to identify the weight of the W such that kaninga system will be still be in equilibrium. What will happen if the stress in member AB is greater than 100 and the stress in member AC will be greater than 120? What will happen to your system? Ngayon yung mga classmate, the
Fail
system
siya,
will
sir.
fail. So, what type of failure ang imong expect? Ano?
Mabugto to or
Mabugto. Yeah, that's a very good one. The other one will be, it may mabugto, maputol lang imong AB or AC. That's a possible. Another one is AB will be elongated or AC will be elongated. Mutaas siya pag maayo. That is not a failure. It is still considered a failure, but the system is not in a collapse state. Because when you say collapse, putol good, katong nabugto or something that is in a collapse state. We can also say that the system fails if one of this system kanang ni
Compressor, isa.
ni elongate siya pag maayo such that na-exceed na niya ang maximum elongation sa imong system. In that case, there will be some kind of a permanent deformation sa imong system, and we want to avoid that permanent deformation sa imong system. So for example, ni taas from this position, and then dako kayo ang imong low W such that kani nga system ni isa, and then this one ni ana, and then diri na siya. So there is now this change in length of AB and AC. Tama? Hello. If you suspend this with a very heavy object kanang bugat kaayo, chances are your AB will be elongated and your AC will also be elongated such that mutaas na siya pagkayo, and that level of elongation ma-exceed na siya sa imuang modulus of elasticity, then there will be some kind of a permanent deformation sa imuang system. So if you remove the load, your system will not go back to its original position. This 100 MPa and this 120 MPa is the limit such that if this W, for example, you load a certain amount of W here, and then you remove that one, your system will still go back to its original position. Now, there will be no permanent deformation that is happening in your system. That's why we put a stress limits to our materials, because we don't want permanent deformations. And so much for that, if really the load is very big, there will be some kind of collapse in the system. And we don't want that to happen. Okay? So that's why morning, I want you to will be familiar with your stresses. So ako question, Kim de la Torre, what do you think nganong this system AB and system AC has different compressive stress?
Kay lahi man ang ilahang kuan sir kaning length sa AB ug AC.
Because lain-lain sila og length. Mo nang different. Ganina, di ba? When I draw this figure, they are of different length, but you do not consider the length as your basis for stress. Tama?
Yes,
Yes, sir.
Yes, sir.
Does the length matter when we calculate stress? Obviously
No, sir.
not. So the length is not a factor here. So why do you think nga lain-lain sila og kuan?
Ilahi sila area, sir.
Area,
Because of the
area,
angle,
Area, sir.
Area
Yeah.
angle, sir.
No, wala
Area,
pa
sir.
kay but yes, lain-lain
Because
sila
of
area. Manong lain-lain sila stress? Because there's really one specific answer for that one, and I want you to think of it. Sige, give it a try, Tristan Carlo.
Kuan sir, kining tungod sa iyahang angle guro sir. Nga na
Okay. Sige,
And so
anyone
the
would like to
question,
volunteer?
sir?
Ang akong question is, nga nung the system AB and system AC has different stresses, has different capacities in terms of stress.
Basin kay lahi-lahi sila area, sir.
Yeah, that's one also. What if I make it what if I make these two materials of the same area? I mean, I make these two systems of the same area, and still I get the same stress.
Angle.
Because of the
Still I
force.
mentioned, ah,
Iyan,
Angle.
angle. No,
iyan
angle is not
diameter,
correct.
sir.
Wala ta nag-mention diri of diameter. This
I
could be
think
rectangular. This could
length, sir.
be, yes, length. No, we already disqualified length because katong based sa atong example ganina, when we calculate stresses, length is not a factor. Because probably these members AB and AC are made of entirely of different materials. That's why they have different stresses. Probably the other one is made of bronze, while the other one is made of aluminum. That's how you look at it, guys. Okay? Probably these two materials, probably these two members, the member AB and member AC, are made up of different materials. That's why they have different stress capacities, because each materials have different stress capacities. The bronze has a different stress capacity than that of steel, that of an aluminum, and other metals. It is also different from the glass and the steel and any other materials you can think of. Okay, so these materials, because members AB and AC have different stresses, because probably they are made of different materials. So that's the answer to that question. So how are we going to calculate for the maximum safe load that we can apply in this system? Ako sa siyang screenshot. Okay, para we can wait sa ako tagtangon imo. Sayang ito tangtang. Oh, my. Anyway, ito lang siyang drawing dito sa 70-30. Okay. This is your bar. Mag-aaka here. Don't like the look. Magpasensya na yun sa akong drawing ha. Kaya di ko ka walang drawing na. Pasara akong drawing sa una kay. Then this is the load W. So this is W, and then our angle, maybe sub 10 is kila ganito, 70. 70 din no?
Sir.
Yes, sir.
Yes, sir.
70 and 30. The other one is 30 degrees. This is point A. This is point B. Then this is point C. Ay, is it? No, A, B, and C. This is point A. This is point B. This is point C. So what we know so far is that the area in member AC is AB rather. AB, the area in member AC, and then the stress in member AB, and then the stress in member AC. So what is the area in member AB? 800, 400, and then 110 Newton. 800, 400. $110 and $122. So mo ba ni siya class? So this is the information that we know so far. So this is the information that we know so far. How can we calculate the maximum weight that our system can support?
Force triangle, sir.
Force polygon.
Force polygon. You can do, yes. So since kabalo na mo sa force polygon, then actually, I'm not really a fan of force polygon, but I am more kind of fan into a kind of summation of forces horizontal and then summation of forces vertical. So let's do it that way na lang sa. But you can also do it in a force polygon and then you do it as the law of science. You can calculate the force in member AB and then the force in member AC. But let's do it my way. So if you take summation of forces horizontal, what are the forces involved? What are the forces involved, class? When you take summation of forces horizontal?
Negative BC cosine 30, sir.
Yes, that is correct. So let's go on para sa benefits sa uban. So this one has a vertical component and then this one has a horizontal component. So this is FBY and then FABY and then FABX and then FACY and then FACX. Can you na-follow lang na ganang dapitan, no? Class?
Yes, sir.
Okay, so when we take
Yes,
summation
sir.
of forces horizontal, so what are the forces going to the left?
Negative AB cos 30.
So FAB going to the left, going to the right is equals to going to the left. So going to the right sa ta. So that if FAC cosine 70 degrees gets sa tanan, right?
Yes, sir.
Do we
Yes,
have
sir.
do we have other forces going to the left? And to the right?
Wala na, sir.
So
Wala na, sir.
going to the left is equals to going to the right. So this is F. What is this? AB cosine what?
30.
30, sir.
30, sir.
So this is our first equation. It's akin. May memo. Ang basahon. Vice President for Administration and Finance. Okay, sige ba? So how about if you take summation of forces vertical? So forces going to the up is equal to forces going down. So forces going up is what?
Sine 7.
FAB side 30 plus FAC
Sine
side
70.
70 is equals to W. Tama?
Yes, sir.
Sir. Yes, sir.
So we have two equations. We have equation 1 and equation 2. And we also have two unknowns. We have three unknowns. We have FAB, FAC, and then W. So let's substitute equation 1 into equation 2, but let's first from equation 1, FAC cosine 70 is equals to FAB cos 30. Then I just want to know FAC. So this is FAB cos 30 all over cos 70. So this is 3. Let's plug equation 3 into equation 2. Therefore, we know FAB. So from equation 2, we know that FAB sine 30 plus FAC sine 70 is equals to W. So let's plug equation 3 into the equation 2. So we have FAB is equals to W. We have W minus F. Ilan man yung class? FAB sa ta. FAB sine 30 is equals to W minus FAC sine 70. And then I want just to know FAB is equal to, and then plug FAC diri. W minus FAC is FAB what? Cos 30 over cos 70 divided by, ayaw, sana lang. Let's make it as one, sana lang, FAB sine 30. So, let's combine FAB. So, pila man yung FAB sine 30, this is, I think, 0.5. 0.5 FAB is equals to W minus, pila man yung FAB, cos 30 over cos 70, pila ni class? I think sine 30 is, I think, sine 30, yeah, this is 0.5. Cos 30 divided by cos 70. 2.53.
2.53, sir.
When you if this is an exam, you carry all the digits by i-save this i-store ni mo ni siya nga digit. Kabalo mo sa siya pag-store no, like shift store, and then you choose A, B, C, D, E, F. Kabalo na mo na, no? So this is 2.532 AB, FAB. So FAB. So when you combine this one, this is pila man eh. So 2.53 plus 0.5 is equals to 3.032 FAB is equals to W. Therefore, FAB is equals to W over 3.03. So, pila man sa class? So, 1 divided by W, this is 0.3298 W. So, this is your FAB. This is in equation 4. And when you substitute this one, store yun siya class ha? Store. So, I want you to store every digit. Although, the way nga inyo siyang i-present, but at the final answer, pag the final answer na mo round off. Okay? Hello? Nag-gets ninyo ang akong buti pasabot?
Yes, sir. Yes, sir.
So, you carry all the digits, and then pag sulat na sa final answer, dirada na to i-round off into 2 decimal places. So your FAB is this one, and then your FAC. So we're using equation 1, we can use equation 1. What is in our equation 1? FAC cos 70. Cos 70 is equals to FAB, what's that? Cos 30. Cos 30. So let's substitute this one. Let's substitute FAB this to this one. So we will have FAC is equals to 0.3298 W cos 30 divide cos 70 degrees. So, pila ni? Times cos 30 divided by cos 70. 0.8, tama ba, class? Pila ni siya karon? In terms of W. Pila, class? Cos 30 divided by cos 70.
0.83.
0.835, I think. Ha?
0.84. Sakto, sir.
I
0.84.
think this is if you will use if you store every digit. So I think you will get this one. So this is equation 5. So now we will now plug in this equation. So we know that the force in AC is 0.835 W and the force in member AB is 0.3928 W. So we will now be able to calculate. So by plugging in the stress, so calculate W. So we will now be able to calculate W. So kung sa ganitong stress na to? Stress is just the force over area. So when we already know the stress, we already know the area, and then we can now calculate our F in terms of this one. And if we plug into this equation 4 and 5, we will now be able to get the maximum safe load W. So the force in member AB is just the stress AB times the area AB, correct?
Yes, sir.
Yes, sir.
So what is the stress in member AB? The maximum stress in member AB is 110. And what is that MPa?
Newton per meter.
Newton per meter squared.
Newton per millimeter squared.
So Newton per millimeter squared. But that is MPa, meaning to say Newton's MPa is Newton mm squared, di ba? The Pascal, 1 Pascal is Newton per square meters. Tama?
Yes, sir.
Sir.
Yes, sir.
So 1 MPa, 1 megapascal is pila na siya?
100,000.
Mega meaning to say that is
Million.
1,000,
1 million
1 times 10 to the 6. So mega meaning to say that's a million. So you multiply everything by a million if that is in Newton per meter squared. So that is the 1 MPa is 1 times 10 to the 6 Newton per meter squared. So this is actually the MPa, Newton per meter squared. But your unit here is in MMM. So if you try to our unit for the area is in terms of mm, tama? Our unit for our area is in terms of mm squared. However, MPa means Newton per square meters times 10 to the 6. So if you convert that meter squared to millimeter squared because we want to have a consistent unit. So this is 1,000 mm per 1 meter. Tama ba?
Baliktad siguro, sir, para makancel ang meter squared.
Yeah, correct. So 1 meter, this is 1,000 mm. And since our unit is in squared, so we have to square both sides para ma-cancel out. So this meter will cancel out, and so therefore this becomes 1 Newton per mm squared. So may mo na siyang your MPa is just equal to Newton per mm squared. But if you say something like that, so this is in Newton per mm squared na. So times the area, what is the area? sa itong area na to, class?
110.
800, I think. So, cancel out ang mm squared. So, we will have the force nga force AB with a unit of pila ni sa class?
88,000.
88,000 Newton.
88,000, sir.
88,000.
newtons or 8,888 kilonewtons. So, we substitute that one into our equation 4. So, we will be able to get, so 88,000 Newton is equals to 0.3, 0.3298 W. So, pila tong W plus? This is Newton. So, 88,000 divide, or 88 kilonewton na lang para dili kay taas. So, 88 kilonewtons divided by 0.3298 is equals to pila class?
266.83.
So, 266.82. 83, correct. Correct, 83 lang. There's 2 decimal places. Kilonewton. And how about for the other one? We have F AC, we have stress AC times the area AC. We will have 120 Newton per mm squared times what? AC is 400. So again, cancel out ang mm squared. So we will have with the unit of Newton na lang. So FAC, ilan ni?
48,000 Newtons.
kilonewtons.
48,000 newtons or 48 kilonewtons. So if we use equation 5 to calculate W, then we will be able to get 48 is equals to 0.835. So how much is the force W?
57.49.
57.49.
7.49.
57.49 kilonewton.
Kilonewton.
So between these two, so we have the two values of W. What is the maximum safe load that the system can carry? Because that is what is being asked.
57.49 kilonewtons, sir.
We have two values here. We have 57.49 and 266.83.
Maximum
So what is
safe
the maximum
value.
safe load? So what is the maximum safe value?
57.5.
Correct. So therefore, the maximum, you really have to have a conclusion. Therefore, the maximum safe load is 57 point. So this is what I will be looking for in the exam. So this conclusion. So if dili ka katagana because the question asked for the maximum safe load and you have two loads, and if dili ka katag na ko ani, then wala kay points. This is where I am looking. So you always have to look ug unsay gipangayo sa questions because the question asked for the maximum safe load, then you have to answer the question in the end. Okay?
Sir?
Yes,
Sir,
sir.
excuse me, sir. Pwede ko ba mag-screenshot na, sir?
Pa-screenshot ani?
Oo.
Sige lang, ako nang isang isend sa ating GC.
Okay, sir.
Sir,
Yes, sir.
nakapunta.
Yeah, kasi na pumunta na.
Ay, ako sir. Nagpapay na sir. Kanang sa part sa kananing stress kini sir. Diba, ang unit na sir is megapascal sir. Nganong wala? Pag-convert sir, nganong wala nag-divide sa 1,000 sir?
Asa man?
For example sir, dra sa katang nai
Diba? The unit is, what is the unit of megapascal?
kwan sir.
1 Pascal is Newton per square meters. 1
Yes, sir.
megapascal is 1 times 10 to the 6 Newton per square meters. That is 1 megapascal. Tama?
Yes sir.
So 1 megapascal. So let's convert this 1 megapascal Newton per Newton per m squared in terms of Newton per mm, because our unit of area is in terms of mm squared, right?
Yes, sir.
So let's convert this meter squared to mm squared. So we have to convert that one. So this is 1 meter and then 1,000 meter. 11 millimeter rather. So since this unit is in squared, so we have to square both sides. So this one, makancel na nato itong squared. So therefore, we have 1 times 10 to the 6 Newton divided by 1 times 10 to the 6 mm squared. Na-follow ni mo?
Ay, sakto na, sir. So, inapa na 1,000 na, sir. Sige, sir. Thank you, sir.
So makancel ni mo siya. So this becomes 1 Newton per mm squared. So this is also in terms of MPa. So 1 MPa is equal to 1 Newton over mm squared, or ano siya, 1 MPa is equals to 1 times 10 to the 6 Newton per meter squared, or is also equivalent to 1 Newton per mm squared. So because both lain-lain tang denominator. If you use meter squared as the denominator, then you have to multiply it by 10 to the 6. But if the denominator is only mm squared, then muna na siyang, we use it as it is. Yan siyang 110 MPa. This is also in MPa. Okay, nasabtan na ba? Hello, nasabtan
Yes, sir.
na?
Yes, sir.
Okay.
Yes, sir.
So, any questions?
None so far, sir.
So, we will have more so more breaks ako mga 5 minutes and then we will continue with the discussion. Actually, we will continue with the discussion sa aming topic on ikuan na. Have you discussed trusses? Class, have you discussed trusses sa inyong statics? Hello? Hello? Naka-discuss ng trusses?
Wala pa may kasugod, sir.
Wala, sir?
Ay, sa statics, joke.
Statics. Hello? Naka-discuss na mo trusses sa statics?
Wala, sir.
Wala, sir.
Wala, sir.
Wala, sir.
Wala, sir.
Oh my God. Topic of trusses is one of the good. Taas siya, but I don't know. So, ako siya. Sige lang. We'll try to discuss trusses at the next meeting because trusses is also part of stress on the discussions on stresses. So any questions kabahin sa stresses? Simple stresses. Inani. Last one. Drawing ko of so for example, you have a wood planks here. Basta wood kunuhay na sa class. And then, ako yung box dire. And then, I apply the force P here. Can you ma-imagine in your class ang answer kong gidrawing?
Yes, sir.
Medyo bati siya, but sige lang. Try to analyze. So for example, you have a wooden one here, kanang a log, or say tawagan na niya, basta kanang siya. And then, naapoy steel plate of that dimension, a rectangular dimension, steel plate, and then in that steel plate, I push the steel plate such that it will generate a stress sa imong system. Asa na to makita or where is unsa nga stresses ang mo develop sa ato ang log kaning kahoy? Asa mag-upor ang atong compressive stress? Class, compressive stress. For example, circle. And then this is the log. So muna yung ako ang log. A steel plate. Asa na develop ang ato ang compressive stress? Class, asa na develop ang ato ang compressive stress?
So steel plate, sir.
Steel plate.
We have a compressive stress sa ato ang steel plate, and then also we also have a
Sa
compressive
kahoy.
stress diri sa ato ang kahoy. Asa man ang atong steel plate? So for example, if you draw the free body diagram of your steel plate, it's going to be like that. And then this is the internal resistance among steel plate. Tama? Force among steel plate. This is your force P. So your steel plate is experiencing somewhat a compressive stress. There, and then also there is a kahoy. If you draw the fluid body diagram of that, so may kahoy, there is a section. This is your force P. Then your kahoy will also have force ay mga wood. So your force in steel plate is equals to P, whereas your force in steel, I mean sa imong wood, is also equal to P. Now this wood will be experiencing is what you call a compressive stress. But that compressive stress is just to call the average compressive stress, because any portion of that wood, we assume that your wood will somewhat have a resistance. During the pita, stresses will be developed all throughout sa body sa imong wood. We try to assume it nga in such that way. And by assuming this is what you call the stress or the average stress. But in reality, what really is happening is your stress ay mga wood will be zero during the pita and then will eventually gradually increase during the pita. So this is what is really happening. Can you imagine, class? Now there will be from the edge of your wood, since wala siya force na gi-apply, the stresses gradually increases until such time na makover niya ng entire area sa imong plate. That is where there will be some kind of a concentration sa imong stresses. So at that portion, there is a maximum and then there is also a minimum stresses na na-develop sa atuang wood. The minimum stress is at the edge of the wood because wala kayo na spread ang atuang force dirang dapita. And however, dira sa tunga, there will be some kind of a maximum stress concentrations dirang dapita. However, this topic will be so advanced nga dili nato ni siya wala nato ni siya gina-discuss. We are only discussing these stresses. Kani nga to nga stress nga gimin, the stress that we mean is force over area. We mean this area as the area na kani siya the entire area. So these stresses that I'm talking about is what you call the average stress. Because the actual stress looks like this. Naminaw pa muna ako. Or this is too much to take, no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Oh,
Stress, sir, nara
so
sa
the one that I am discussing, is actually the case na kaning there is a PCAS. Now we are assuming that the entire block has the similar stress. But in reality, what is really happening is that some parts of the block will have more stress as compared to the other. This is really what is happening. But this topic is an advanced topic na siya. When you take master's degree, this is where you will be mostly considering about. But in the undergraduate program, we're only focusing on these stresses. Because this type of stresses, nga kaning diri nga, there will be some kind of stress contour na ma-develop. That is what you call, we will now consider that in the what you call a finite analysis. Will be considered in the finite analysis. And wala na nato siya giniskuha. Pakitaon ta mo itsura sa stress. Stress surface. Yung sa hangin ako. Para ra kanang murag na mo idea ba nga we are talking about stress can happen kanang murag stresses have different kanang itsura ba. It's just that here in this topic, this is just a very simple stress nga ang atong kuan. Plate stress. Let me take this. Share screen. Makita rin yun sa akong screen class?
Yes, sir.
Yes, sir. Yes, sir.
Hello?
Yes, sir.
Oh, so inanin. So can you see the different colors here? This is actually what is happening really if your stress is not gradually distributed sa imong surface area. So this is what you call a stress contour. So the other portion, which is the blue ones, are the ones experiencing less stress, while the red ones are experiencing much greater stress. So in ano yung may tabo. So if this wood, although this will not really bend, but if this wood is just made up of a thin plate, and then you apply the force P here, then you will have some kind of a deformation sa imong system. And that is what really is happening. Mugyo na siya ang actual nga stress distribution. And this topic is what you call the finite element method or the finite analysis. But we will not be doing a finite analysis here. Instead, we will assume that the red here does not we will just assume that the entire surface has an average stress. So for example, if the stress in blue is 0 and the stress in red is 5, then if you take an average for that one, then the stress here is just 2.5. For the entire surface area, we assume that the stress is just 2.5. Nagets ninyo yung concept class of the average stress. Mo lang to siya. Ako lang siyang i-share sa inyo. So one last question. So where do we have shearing that is happening in this system? Do we have shearing stress nga nahitabo sa ato nga system? Victoria.
None, sir. None,
Wala.
sir.
Okay. Ano man?
Because the stress that is present on the sir, on the figure is only compressive. It's being pushed down, sir. So there's no
Correct,
action as if they're sliding past each other.
Correct. Very good. Do we have a bearing stress here, Fred Arden? Okay. Arden.
Yes, sir.
Arden. Are we experiencing, do you think there will be some kind of a bearing stress that is happening in the system?
Yes, sir.
Huh?
Yeah.
Arden. Yes, yes. Naan ba tayo bearing stress na naitabo diri sa ato nga system? Arden. Anyone would like to help Arden? Sige, Shilan, feel. Shilan, feel. Wala. So, si Shilan.
Hello, sir.
Precious April. Oh, yes. Shilan, sige. Do we have a bearing stress during the pita sa ato nga system?
I think wala, sir.
Wala tayo bearing stress. How about Ruiz Algin? Ruiz? Ruiz Algin. Hey, Ruiz. Wala si Ruiz Algin. Wala na minaw. Tristan Carlo Memes. Tristan.
Sir, I think
You think what?
wala guro sir. Wala Silang wala sir.
Wala tayo bearing stress. Wala ba good class?
Nah, sir.
Wala, sir. The point of contact.
Naatay bearing stress nga naitabo. Asa dapitan atong bearing stress? Where is the bearing stress happening?
Kanang
Sa four sides, sir.
Sa ilalo.
Correct. This is where our bearing stress is happening. There is atong shading F. So muna itong bearing stress because this is the point of contact between two separate bodies. Our first body is the steel plate and then our second body is the wood. And then the point of contact between the two is where the bearing stress occurs. Okay, sa katong mga wala katubag, so I don't know if naminaw mo ganina, but sa katong mga to nakatubag, ay okay, naminaw mo.
Naputoy compression, sir.
This is the compressive stress. Kanina akong ginapakita diri.
Pero napoy
But the compressive stress that is happening here is just the average stress because the actual stress is actually looks like karing na diri sa right side kani akong gina-checkan. This is where the actual stress happens, but in our discussion we are just trying to average everything. So we are using the concept of the average stress.
Sige, sir. Thank you, sir.
So I will give you exercises for you to work for. So basta masend ako na siya tomorrow with regards to just stress analysis. So the next on our next discussion, we will still be continuing with the discussion of stresses. Probably before we continue with the discussion on stresses, we will have a discussion on stresses first, and then we will continue with the discussion of stresses. And then after that one, we can have our first exam. And then after the first exam, we will have our midterm exam on the second week of April. So any questions, class? You have to really perform in this subject because kabalo na mo if dili mo kapasar og mechanics and deformable bodies, daghan kay ni siya nga prerequisites and then mabitay mo sa katuig. So this topic is really, this subject is importante kini sa kayo atong mechanics and deformable bodies. I'm not saying na dili importante itong uban, but I'm saying that as a civil engineering student, this is really a priority sa inyo nga makabalo mo sa atong mechanics of deformable bodies and then later on theory of structures. Because dako kayo ni sa og points sa board exam. Ana. So, okay, any other questions, class?
Sir, excuse me, sir.
Yes, Kevin Lee.
In terms sa unit, sir, ba, pwede mag-like kay, for example, if Newton, abi, ako answer abi kay in kilonewton.
Yeah, no problem. I know kabalukod sa una siya. So, doesn't matter sa ako. Kaya ako may mag-check. So, I know
Okay, sir.
what unit is this. So, if you answer in Newton, you answer in kilonewton, that is correct. But if mo answer ka og pounds, because the given here is kilonewton and newton, and then mo answer ka og pounds, then imo na kung hatagan og trabaho by converting kilonewtons to pounds or newton to pounds. But still, I will still consider that if your conversion is correct, then you will still get credits for that.
Okay, sir.
Mm-hmm. Any other questions? So, na ba yung mga nagklase o na pa mo yung klase ron 5 to 1, 5 to 7?
Wala, sir.
Mm-hmm. So, questions class about sa topic of stresses. So, ganahan pa mo sa man, ganahan pa mo daghang examples or sa man ganahan pa. Obviously, we will.
For example, sir.
Yes. Matag paguro kung mga 3 to 4 examples. Once na lang, we will start with the topic on stresses na lang. We'll break sa kong mga 5 minutes and then I will not go through the details muna. I will just mangutanas ako unsay how do you calculate stresses, what are the assumptions when we do the calculation of stresses before we go dig deeper into the topic of stresses. Sa next week or karong Saturday, we will discuss more about stresses because the concept of stresses is very, very important. Yun. Like, dili gyud pwede nga ang usa ka civil engineering student dili ka balo mo compute og trust. And you know what trust is, right? So, balikan ta mo ana mo break sa akong mga 5 minutes when lang kog tubig.
Nagklase ka?
Hmm.
Mana?
Na ba? Ay, niluto. Hala, wala ka kapalit og kuan. Nadaot na siya.
Abay, hindi ako na luto mo.
Hindi mo guni maluto.
Blanch naman ko na.
Hindi mo guni dapat i-blanch. Fresh na mo guna siya kanon. Yan ang nag-mayonnaise.
Ano ko na siya i-blanch na? Kaya isang ulang vegetables. Hindi na siya malata. Basta blanch na.
Hello? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Alam mo na naka-off ang akong microphone. Naka-airpods man dahil ko. Hindi. Naka-lakaw ko yung Instagram dito sa class. Ang na ganito. So when we talk about trusses class, kailan po mo sa trust?
Yes, sir.
Yes.
So what is a trust? So when can you say that a system is a trust?